Welcome to today's lesson on graphing translations. In the last lesson, we talked about the communications, what's happening to the parent function. Today, we're actually going to be looking at the graph and how does the graph move or transform based on the operations that are being added to it. One thing we want to think about is, a transformation is just a machine. The parent function is what we start with. We input an initial piece and we get our output, so just like putting in the work through the machine, and then we all end up like Popeye in the end. Going back to our lesson from yesterday, we always want to remember the high-low rules. Any horizontal adjustment has to be inside the parent function. Okay, and then we also have the head shake rule, which tells us to don't trust what you see operation-wise. So if it's a plus, you do the opposite. And as we work through the rest of the lessons in this unit, we'll see how we don't trust some other operations as well. Any vertical operation is outside the parent function. That vertical head shake tells us we do trust what we see value-wise. So just some, more specific terms. What happens when we subtract outside the parenthesis? Okay, outside is vertical, we trust it, so we know the graph slides down. What happens when we add outside the parenthesis? The head shake says we trust it, it's vertical, it's outside, so the graph moves up. And then we have our inside operations. Okay, if we subtract inside, we don't trust the subtraction. The graph actually moves to the right, so it's a plus operation in the table. What happens when we add inside the parentheses or inside the parent function? The graph slides to the left. Okay, so now, as soon as you see a transform function, the first thing that you want to identify is what is the parent function. So our parent function in this case is y equals x squared. So we want to start with those initial values. First thing that we always want to do is we want to test 0 in any function. 0 squared is 0. 1 squared is 1. 2 squared is 2. Okay, and let's actually put these onto the negative side so we're working left to right. When we have a positive 1, we get a positive 1 output. We put in a positive 2, we get a positive 2 out. So we have this initial graph, and it's always helpful to put the initial points on the graph. We don't want to connect them because that's not our final destination for this graph, but that is where we start. So now, what's being added to this function? We've got a plus 3. Plus 3 is on the outside. We know outsides are vertical. Okay, we've got a vertical head shake that tells us that we trust what we see. So we know that this graph is going to move up 3. So if we want, we can do that transformation. We're going to move every point in this graph up 3 units. So we take that 0, 0 point, we move it up 3. We take the negative 1, 1, positive 1, 1, we move those up 3 units. And then we take our last point, negative 2, 4. We move that up 3. And positive 2, 4, we move that point up 3. Now, this is our transformed graph, so we do want to complete the sketch of that graph. Okay, now, the other piece that you can do to check and verify your work, we understand that a vertical adjustment only affects the y values of the graph. So if my y's are moving up 3, head shake rule tells me I trust the operation. So I'm actually adding 3 to all of these y values. So it's the 2 plus 3, the 1 plus 3, 0 plus 3, all the way down to get our new y coordinate for this graph. And then what we can do is verify that we've done our operation correctly by taking a look at any one of our coordinate points. Okay, that coordinate point has an x value of -2, a y value of 1, 2, 3, 4, 5, 6, 7. Okay, so I don't want to look at the table yet. I'm just looking only at the coordinate point. So now if I plug a -2 into this function, just like we did in our last unit, okay, inserting values and solving, -2 times -2, or -2 squared, is 4. Be careful if you plug this into your calculator. Make sure that you include the parentheses. Okay, otherwise you will get an incorrect answer. 4 plus 3 does equal 7. So I verified that point and I know that it's correct. Okay, looking at our next operation, we're still, how do you identify the parent is always the first thing that we want to look for. Okay, identify your parentheses, find the variable, and see what is the consistent thing. Okay, we only have our 5 parent functions, so it's either an x squared, an x cubed, an absolute value, a square root, or a inverse of 1 over x. So we've identified the parent function. Okay, we've got f of x equals x squared as our parent. So we've got -2, -1, 0, 1, and 2. Our y values are 4, 1, 0, 1, and 4. Now, once we've identified the parent, we want to identify what operation is being done. Okay, we have a -3 inside the function. Insides are horizontal adjustments, and our horizontal arrow, horizontal head shake, tells us that we don't trust what we see on the inside. So even though it's a negative, this graph is going to move to the right 3 units. Okay, now if we want to think about the operation that's going to happen to the table, horizontal adjustments affect your x values. So what's happening to the x value? We want to look at the operation that we've stated, not the sign and the value. So to move a graph right 3, all of our x's have to be added to 3. So we're going to add 3 to all of our x values. Okay, and we have our new transformed value, which we can graph. We'll also look at it on the graph itself and moving the points there. So -2 plus 3 is 1. -1 plus 3 is 2. And then we've got 3, 4, and 5 for those values. So now, if we look at the original points, okay, this time we'll do the original points for the x squared in blue. Now what we know is every one of these coordinate values is going to move to the right 3 spots. So we move each point to the right 3. You know, in some ways it's just a counting game to make the new graph. And then once we have the points graphed, we want to connect the values to draw through and show that transformed function. Okay, now, working with a new parent on this one, we've got an operation inside and outside. Okay, so once again, step 1, identify the parent. Where is your x value? What is the main thing being done to it? In this case, it's absolute value. So that gives us our initial table, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. Okay, so these parent values are something that you do want to work to memorization on, because we are going to use these a lot overall. And then now when we look at our 2 operations, we have a -4 on the inside. Insides are horizontal transformations, Head shake rule tells us we don't trust what we see for that transformation. So this graph is going to move right 4, or our x's are going to be added by 4, or adding 4 to our x value. And then our next operation, we've got a plus 5. That plus 5 is outside the parent function of the absolute value. Outsides are vertical. Head shake tells us we trust what we see. So this is an up 5 adjustment to the graph, or your y values plus 5 for the graph. So now, starting with the original parent points, okay, the absolute value is a V-shaped graph. When you're looking at what does the graph look like overall, we've got 2 adjustments. We can actually apply those both at the same time. So we can move every point right 4 and up 5. Okay, so I move that center point first, and then every point moves in accordance with that. 1, 2, 3, 4 to the right, 1, 2, 3, 4, 5, and then we can complete the graph from there. Okay, looking at an additional parent function, the inverse. So the parent of this graph is the 1 over x function. Okay, probably one of the more involved parent function graphs. Okay, we need a -2, a -1, but we also now have to include a -1/2 because 0 doesn't work in this function. So we want to include the 2 points on either side of 0 so we can see what's happening with this original graph. So when we plug in a -2, we get a -1/2. When we plug in a -1, we get a -1, -2, +2, +1, +1/2 for the graph. So our initial graph has kind of a butterfly look to it. So we've got 2 distinct parts to this graph because when you plug in 0, 0 does not work in the function. Okay, looking at our transformations, we got a -2 on the inside, horizontal. Head shake tells us we don't trust what we see. So this graph is going to move to the right 2, or my x's are going to be added by a factor of 2. And then our vertical operation, we've got a +3 on the outside. Outsides are vertical. Head shake tells us we trust what we see. So we know that this graph is going to move up 3 units. Or the y values will be +3. Okay, so once again, we can move these pieces. Now when we're looking at this inverse graph, we do have what's called the asymptote values. Okay, values that the line gets very close to but can't touch. Originally, it's y = 0, x = 0. But in this case, the asymptote lines move with the exact same operation. So it's going to go right 2 and up 3. And what we have is we have now these 2 dotted lines, okay, that we use for asymptotes. Okay, once again, values that we can't touch, but we get extremely close to for our graph. So now every point gets moved right 2, up 3. So here is the upper portion of our graph. Okay, once again, gets very close to those asymptote lines. And then we have the lower portion of our graph. It gets very close to the asymptote lines. Okay, once again, if you want to verify, do I know that I did this graph correctly? Identify a point and test it into your function. So this point here is x equals 3, y equals 1, 2, 3, 4. So now we want to test this into our function overall. Okay, so just like we did in the last unit, okay, we're inserting the x value into the equation. 3 minus 2 is 1. 1 divided by 1 is 1. 1 plus 3 gives us the output of 4. So now I've tested a point, and I know that I have drawn this graph correctly. Okay, so that's the end of our lesson on graphing transformations. Good luck on the homework.